about part 3. Okay? So let me kind of give you the setup. So here's what you're going to do. You're going to go back to the program, clear everything. Somewhere over here towards the right side of the screen, you're going to stack 2 positive charges. Exactly 1 meter away, you're going to put a single negative charge. So what you're going to try and figure out is a theoretical location where the electric field can be 0. Okay? Now, let's talk about where it can and cannot be. Would it be possible if I put a positive test charge out here for that electric field to go to 0 if I put it on the right side? Fast, you shake your head no. Why?
You're saying if you put it between like the...
No. I've got the negative, I've got the 2 positive charges.
Yeah.
And I'm going to put it out there to the right of those 2 positive charges.
Yeah, there's no force acting the other
Now,
direction.
none of these are electric fields. These are electric fields. Now, these are not forces. These are fields. So if I put a positive test charge out there, start with this. Mathematically, how do you calculate electric fields? E equals what?
E over D.
No. In terms of distances and charges.
KQ over R squared.
KQ over R squared, right? Yeah, you gotta have that, or we're kind of dead in the water. Is that Q what is creating the electric field, or what is feeling the electric field? It's what's creating it, okay? This is important. That is what's creating it, not as what's feeling it. Just like little g equals big G m over R squared, that's the mass of the Earth that's creating the gravitational acceleration, not the mass that's feeling it, okay? So, here's the story. So if I put, let's just start with the conceptual idea of which direction the field is going to point. So if I put a positive test charge out there, what's it going to feel relative to those 2 positive charges? It's going to feel a push going this way, right? What's it going to feel from the negative charge? It's going to feel a pull, right? Because they're oppositely charged. So at least we have them going in opposite directions. So at least there's a chance because they're going in opposite directions. But when you look at how the electric field is calculated, is there any way, because of the fact that this is 2Q, and that's a pretty small distance, and that's just negative Q, and that's going to be a much bigger distance, is there any way mathematically that those 2 electric fields are going to cancel out? Absolutely not. Okay? So there is no way I can put that charge, a test charge out there, and have that electric field drop to 0. Okay? It's not possible. Cannot happen. But what if I do this? What if I put a positive test charge somewhere out here? Okay? So if I put a positive test charge out here, what's it going to feel relative to that closer negative charge? Repulsion or attraction?
Attraction.
So it's going to feel a pull from here. It's going to feel a push from
Double positives.
the double positives. Huh. Is that conceptually at least a possibility for the field to go to 0 out there? Yeah. Now, what do you notice about this distance here compared to the distance where you have the 2 positive charges? That distance is going to be smaller, right? Now, here's what you're going to try and find. And this is an algebra problem, basically. You want to find the distance, and it's not and it's funny, when you write test questions or questions on a lab, you always, in your mind, you don't need to clarify it because you wrote the question and you think you know exactly what's going on. So what I'm telling you to find is calculate the distance if it exists at which the electric field will drop to zero. So in my mind, that was implied, oh, it's going to be from that negative charge because it's out there. And some kids are going, do you want it from the negative or from the two positive charges? Like, okay, so just for clarification, when you give this answer, it's going to be from that negative charge. Now, here's the story. Are you going to have two electric fields? That's the whole point. It's the only way they can cancel out, right?
Yes.
You can't cancel out, you can't have zero net electric field if there's just one of them. So what do you know about the two electric fields? They have to be
Add on to each other.
equal and opposite, right? So we're going to let this distance, you can let it be x, r, d, I don't care, pick a distance, okay? I'm going to put it as r. If you want to put it as d, I don't care, I'm just going to make mine r. So here's what's going to happen. So how could you express the electric field that it's going to, this is where I'm just going to talk you through it. Think about how you could calculate the electric field that this positive test charge is going to feel from this one, okay? Then think about how can I express the electric charge or the electric field that it's going to feel from this one. Now, obviously, this one is going to have a charge of Q. Don't make it difficult. Let it be Q. That charge is going to be what?
2Q.
2Q. Okay, now if you're a numbers kind of person and you want to put in 1 nanocoulomb and 2 nanocoulomb, you can if you're a numbers kind of person. So if this distance here is R, what's going to be that distance? 1 plus R. But what are you going to have to do with that distance?
Square it.
Because it's over R squared. So what you'll see is that leads to eventually using the quadratic formula to solve this problem, because you're going to have 1 plus R squared. Now, here's the beauty of this. You're going to get a distance. So basically what's going to happen is that you're going to get two possible routes for this solution. One will make no sense because it's going to be a negative value. Okay? So one's going to be a positive value. Here's what the beauty of this is. You can set this up and then you can test it to see if you're kind of right. Okay? And again, if you're off by a little bit, it won't necessarily read 0, but you're going to get a pretty good idea if it is or isn't. Okay, so you got some calculations to do. Yes, at some point you got to use the quadratic formula. In number 8, this does not have to be a whole bunch of lines. So what you're going to do on number 8, what I'm looking for on number 8, is you're going to say, okay, here's my negative charge, here's my two positive charges. I want a couple of things. I want you to sketch in some field lines, some voltage field lines where you have equal lines of voltage, not just one. Now, you don't have to make this look like a Rembrandt. Just give me some lines, okay? They don't have to do a whole bunch of them, just some. But the other thing that I want is draw in the field lines. Which direction are your field lines going to point? So are they going to be pointing towards it? Are they going to be pointing away from it? What are you going to have? So on number 8, again, this does not have to be this big fancy drawing. But all you're trying to convince me is that, hey, Bergkamp, I understand, do these lines cross? Do they not cross? Are my field lines pointing towards the positive charge or are my field lines pointing away from it? So, make that happen, stop yonder camera.